All right, today we are tackling something pretty incredible. We're asking, could a simple sugar molecule, the kind you find in things like yeast and mushrooms, actually hold the key to repairing our central nervous system? You heard that right. We're talking about hacking our own immune system to heal nerve injuries. Let's get into it.
So, first things first, we have to understand the core problem. You get a cut on your arm, and your body is amazing at patching it up. But when the spinal cord gets hurt, that whole healing process just grinds to a halt, and the results are often permanent. So what is it about the central nervous system that makes it so different?
Well, the answer really lies in the spinal cord's unique environment. After an injury, the body's reaction, which is supposed to help, ironically, becomes a huge part of the problem.
I want you to picture a panicked construction crew rushing to a collapsed tunnel. Now, in their panic, they don't actually clear the rubble. They just pour concrete over the whole mess. That's kind of what happens in the spinal cord. The immune system floods the area, causing massive inflammation. Then, these cells form a thick, dense scar. It's called a glial scar. And this scar then releases all these molecules that scream stop to any nerve fibers, the axons, the long communication wires, that try to regrow. The fix actually prevents any real repair.
Okay, so if the body's own immune response is the bad guy here, what could possibly be the solution? Well, what if the answer isn't to shut the immune system down, but to give it a totally new set of instructions? And that's where today's star molecule comes into play.
Meet beta-glucan. It's a complex sugar our bodies can't make. It's built into the cell walls of things like fungi and bacteria, and because it's foreign, our immune system is expertly trained to recognize it as a sign of a potential invader, a signal that something needs to be done, and fast.
And listen, this isn't just some lab theory. A 2022 case report on a human patient showed that doctors already measure beta-glucan in spinal fluid to track fungal infections in the central nervous system. So we know our bodies are already on the lookout for this molecule, right, where it matters. But the big question is, could we hijack that alarm bell and turn it from a warning of infection into a signal for repair?
Okay, let's look at the actual evidence that put beta-glucan on the map for nerve repair. This is where the story gets really, really cool.
Back in 2015, a team of researchers decided to test a really wild, counterintuitive idea. They looked at that destructive inflammation we just talked about and asked a pretty profound question.
What if inflammation isn't just a single destructive force? What if, instead of being a sledgehammer, you could turn it into a scalpel? Could you trigger a different, a controlled, a pro-healing type of immune response on purpose?
So here's what they did, and this was published in the major journal PNS. They used a mouse model, and to mimic a central nervous system injury, they crushed the optic nerve. This is a great model because the optic nerve is part of the CNS, and, just like the spinal cord, it normally doesn't heal. Then, they injected a specific type of beta-glucan derived from bacteria called curdlan to try and kickstart that special immune response.
And now, get ready for the results, because they are just wow. Look at the bar on the left. That's the control group, the mice who got no treatment. You see basically zero regrowth, just as you'd expect. Now, look at the bar on the right. Those are the mice that got the beta-glucan. The difference is absolutely staggering. We're talking about massive, robust regrowth of those nerve fibers.
The finding was unmistakable. This specific immune signal didn't just help a little, it completely flipped a switch in the body from no repair allowed to full speed ahead regeneration. The nerve fibers grew way past the original injury site, which was something many people thought was basically impossible in the adult CNS.
And get this is what makes it so clinically relevant. The researchers found that the treatment worked just as well when they waited 2 full days after the injury to give it. Now that is a huge deal. In a real-world injury, there's always a delay before treatment can start. This suggests there might be a pretty wide window of opportunity to intervene.
So, you have this incredible result in a mouse optic nerve. The next giant leap, of course, is figuring out how to apply this to the much more complex problem of a spinal cord injury.
The journey from a discovery in the lab to an actual therapy is a long one. So, step 1, you've got the finding. Beta-glucan can signal nerve repair. Awesome. But then you hit step 2, the challenge. How do you get it to the exact right spot, in the right dose, for the right amount of time? A simple shot isn't going to cut it. And that's where modern science gets really creative.
So now, as a 2023 review in the journal Helion points out, researchers are working with these incredible things called hydrogels. You can think of them like a sophisticated biocompatible jello. They can load these gels up with beta-glucan and inject them right into the injury site in rat models of spinal cord injury.
The gel then forms a scaffold that gives the new nerves a structure to grow on, all while slowly releasing the beta-glucan to keep orchestrating that pro-healing immune response. Now, it would be really easy to just stop there and get super excited. But that's not how good science works. Waking up the immune system is like playing with fire. It's incredibly powerful, but you have to be so careful.
And this brings us to a really, really important question. If you use this powerful key to unlock the immune system, what are you actually letting out of the box? Is it always going to be the good guys?
So check this out. A 2022 study looked at this exact question using mouse models of multiple sclerosis, or MS. In the first model, where the MS is caused by the mouse's own immune system mistakenly attacking its nerves, giving beta-glucan was a complete disaster. It was like pouring gasoline on a fire. It supercharged the autoimmune attack and was fatal. But, and this is wild, in a second model where the nerve damage was caused by a virus, the exact same beta-glucan treatment acted like a shield. It actually reduced nerve damage and made the mice better.
So the huge, flashing takeaway here is context is everything. Beta-glucan isn't a magic wand. It's a very specific instruction. In a traumatic injury, like a spinal cord crush, it tells the immune system, hey, time to rebuild. But in an autoimmune disease, where the immune system is already on the attack, that same signal gets interpreted as attack harder.
So let's pull all this together. What does this all mean for the future of treating these awful injuries to the brain and spinal cord?
Okay, here's what you need to remember. First, the immune system, which we used to think of as the villain, can actually be a powerful hero in nerve repair. Second, molecules like beta-glucan are like a key that can unlock that heroic potential. But, and this is the big one, it's a precision tool. Context is absolutely critical. The way forward probably involves clever delivery systems like those hydrogels to make sure the key is used in the right lock. And finally, and this is so important to state, this is all incredibly promising, cutting-edge animal research. It is not a cure for people. Yet.
And that kind of leaves us with a final thought. Maybe the real future of healing isn't about finding a drug that forces our body to do something. Maybe it's about learning to speak the language of our own cells, giving them the right words, the right instructions, at just the right time. And the question this research leaves us with is, what other conversations are immune cells waiting to have? And what will we teach them to do next?